Hello there, this is the solution video as promised to the problem that I posted yesterday. So I don't know if I explained myself very well. Let me try to do it again in case you want to try it before looking at the solution. The problem is that you have a kitchen right here and you have three appliances, big A, big B, and big C. Big A, of course, is bolted to the wall, while B and C are here. And then you have sockets, small b, small a, small c. And you're supposed to connect them so that they can get electricity, right? So they can function. So you're supposed to connect them, cables, right? And the problem is that you can't overlap the cables. So the cables are not supposed to cross. If you made it like this, and this, then this wouldn't work because there's, a crossing here. So question is, how do you do this? How do you solve this? Now, let me tell you, if you struggled with this, if you tried this and struggled with this, that's exactly what's supposed to happen. Because I found this problem probably 12, 13 years ago for the first time in a book. And it took me a little while to solve it. It took me probably like at least an hour or something. Maybe even two. I don't remember exactly. But over the years, I've given it to many people to solve. It's been students and it's been like mathematicians, literally, and everyone struggles with this. So if you struggled with this and you couldn't do it, then don't feel bad about yourself, because this is a difficult problem, even though it looks kind of simple. So with that out of the way, let's see what's so challenging about this problem. So here's the thing. Our brain works in a way where we want to connect things together, right? And so what happens here? Well, our brain immediately sees a big A and a small a, and so it creates an invisible line that goes like this. That's what we do. Whether you want to believe it or not, that's kind of what happens in the brain, at least in my brain. But the problem is, if you do that, you've kind of, put yourself in a dead end, because there's no way you can cross. You can't get the cables, because then it will obviously cross here, and you can't do the cables outside of the box either. That's not allowed. So most people kind of get stuck here because they think, damn, well, if I can't do that, then what can I do? And then they go like this, and then they go, oh, that's the same problem, so I can't do it. And you get kind of stuck in that loop. And problem solving is all about trying to get out of these things where our brain naturally puts us. And that takes a lot of effort and practice and a lot of doing these kind of problems to get good at. So let me show you something here. So one of the things you can do is that there's a concept in problem solving, or a strategy rather, is that if you can't solve the problem that is given, you can create a simpler problem for yourself. So how can we do that? Well, what if you put yourself actually in the kitchen, right? Imagine you are in the kitchen and you can move these appliances around, because you can do that, right? These are not bolted to the wall like this one is. So what if you kind of moved this one over here? So this becomes B and this becomes C, right? So then it becomes really easy, because then you can just connect this one and then this one, right? Doesn't that work? Yeah, it does work. And what do you know? When you've connected them like this, you can put them back into their original places, and you'll see that it will still work. It's not going to overlap. If you don't want it to overlap, it's not going to overlap. So this is just something to note, something that I try to teach my students, is that if you're struggling with the problem that is given, try to invent a simpler problem for yourself. Because you'll see that if you can solve that simpler problem, then going from that to the harder one usually is much easier than trying to solve the original problem just like that. Okay, so that's this one. But how do you really solve this one, though, without doing anything like this? Well, what if we start with not A, because we're not gonna win if we do that. What if we start with B? So how can we connect B to B? Well, okay, that's pretty easy. We can go like this, right? There we go. Okay. Then I'm going to go from C to C. Can we do that? Well, yeah, I see like a symmetrical solution here. We can go this way. There we go. Okay. Now we have the hardest one, which is A to A. How do we do this? Okay, well, if we go from here to here, we can't go through here, right? Okay, so this is a dead end. What about this way? Okay, we can continue here. We can go down here. All right, and then we go up here. Oh, there's a little opening here and down there. Hey, it works. Okay, let's do it. So let's go like that and there and down there. There we go. See? So what did I just do? Well, I solved this problem in 3 separate steps. The first step was the easiest one, which was connect B to B. And then it was slightly harder, but it was a similar one, C to C. And then we go, okay, now we've solved 2/3 of the problem. What's remaining? And then we go the last one, kind of like a maze, right? And there you go. That's the solution to the problem. I hope this was fun. I hope you tried it yourself, but if you didn't, that's okay. Yeah, so let me know if you want more of these problems, because I got a lot more of these, and I find these fun. So yeah, that's all from me. Have a good day.